Hello everyone, I am Pavitra Devi working as Assistant Professor in Department of Computer Science, Artificial Intelligence and Data Science, Dr. SNS Rajashmi College of Arts and Science. Now I am going to take the class about process synchronization. Process synchronization. Process synchronization is nothing but coordinating the execution of process. It has no two more or process share the same resources or data. That is called process synchronization. It has two type of process synchronization. One for independent process synchronization, another one for cooperative process synchronization. Independent process synchronization is nothing but each one of the process does not affect execution of another process. That is called independent process. Next one, cooperative process. Executing one process affect the execution of another process. That is called as cooperative process. It has two type of process synchronization. It requires multi-process system. The process synchronization is nothing but multi-process system. Multi-processor run together. More than one process try to get again share the same resources or data at the same time. The changes are made in one process or not reflect the when another process access the same shared data. It is necessary that the process are executed synchronized with each other as it helps to avoid inconsist of the shared data. For example, a process P1 try to changing the data in the particular memory location. At the same time, another process P2 try to reading from the same memory location. Thus, there is high probability of the data being read by the second process is incorrect. On the basis of synchronization process are the categorized as the one of the following two types. One for independent process, another one for cooperative process. Next one, sections of the program in the operating system. It is nothing but four essential sections of the program in operating system. First one is entry section. Entry section is nothing but decide the entry of the any process. Whatever it comes first, the process, the checks in the entry section. Next one, critical section. This allow the process only enter and modify the shared variable only. Next one, exit section. This allow the process waiting in the entry section until the process is completed. The entry section into the critical section and make sure that the process is removed through its section once it doing the execution. Next one, last one is remainder section. Remainder section is nothing but part of the code not present in the above three section or collective is called remainder section. Next one, critical section problems in the operating system. The segment of the code that the signal process can access at the particular point of the time is known as the critical section. It contains shared resources that can be accessed by another process. First one is wait function. It is represented as P. Handle the entry section of the process in the critical section. Next one, whereas the signal function represent the V function, handle the exit of the process from the critical section. Next one, single process execute in the critical section at that time and another process execute after the current process is done execution. Next one, race condition in operating system. When more than one process execute the same code, access the same memory or shared variable, it is possible that the output of value of the shared variable is wrong. In this condition, all the process of race condition occur in order to prove that their output is correct or not. This situation is known as the race condition. When multiple processes access and manipulate the same data concurrently, the outcome depending on the order in which this process accessed the shared data. When the output of the multiple thread execution differ according to the order of in which thread executed in a race condition occurs. Race condition is nothing but the same shared resources. When we avoid, if we treat as the critical section as the automatic instruction and maintain proper thread synchronization using log or automatic variables. Next one, rules for the critical section. There are three rules for the critical section. First one is mutual exclusion. Mutual exclusion is nothing but the special type of binary semaphore to use it to the control access to shared resources. It has a priority inheritance mechanism that helps to avoid extended priority inversion of the problem. Only one process can execute at that time in the critical section. Second one, progress. Progress is nothing but we use it when the critical section is empty and a process want to enter. Otherwise, the process until wait. The process there are not present in the remainder section decide who should go in within finite time. Third one is bounded waiting. Bounded waiting is the specific number of processes are allowed in their critical section. Thus, the process need to make request when it want to enter the critical section and when the critical section reach in the its limit. The system allow the process request and allow it into the critical sections. Thank you.